So for this problem, we want to find functions that have a minimum value at -3. So looking at these examples, both of these have a positive number being raised to the power of x. So what's important to note is, and let p stand in for a positive number here, when you raise a positive number to the power of x, no matter what, it's always going to be bound on the bottom by 0. Honestly, not even less than or equal to, or just greater than. And this is because if you raise it to the power of a positive exponent, obviously we're going to get a number that's greater than p. But if we raise it to, I suppose, 0, then p to the x equals 1. And then if we raise it to a negative power or a fractional power, either way, the result that we're going to get is still going to be a positive number. It's just going to be a fraction. And no matter what, this positive fraction is always going to be greater than 0 as well. So what this means is, for finding a minimum, we want to look at the possibilities and think, okay, well, what happens when this number becomes greater and it goes up in value? Well, when it goes up in value, then this also goes up in value, so the function becomes lower, right? But we can't have a bound on how high our x can go, right? Because it can go up to infinity. So that doesn't work. But now if we explore the possibility of what happens when we lower the value of x and we make it, say, like a -100, well, then this just becomes an incredibly small number, right? It becomes 3 over 100. And then this becomes smaller, so that actually increases the value of the function. So either way, and obviously the same is true for both, because this also has a -3 in front of a positive number being raised to a power. So for that reason, there are no minimum values, because as x approaches infinity, the value of y, or f of x and g of x, I suppose, gets smaller and smaller, but it never converges to an absolute minimum. Therefore, our answer will be D, neither 1 nor 2.